ये शेयर्ड है स्क्रीन ना? मेरा फोन कहाँ है? So I think screen is visible now. So now we are going to start the coding aspect. So first of all, we will focus on this one, how to start coding. So first of all, we are making a folder here, week 2. So here we are going to code hello world. So first of all, we need to open the terminal, right? Now, as we are creating a solver and we are trying to make modification in the original solver of the OpenFOAM, so we need to write the command foam new app and name of the solver. So here just we are trying to check the coding aspect, so we are just writing a welcome code. Before that, we need to turn on the environment, that is OpenFOAM 6. Now we have to create the solver, that is foam new app and name of the solver. So as you can see, this application file now we have created this that is the name of the solver, that is welcome. If we go inside this welcome folder, we see that there is a make file, there is a .c file named with welcome, and there is one folder which has another 2 files. So if we go inside that make, we see that there are 2 more files, that is files and options. So if we go inside this files and option, we see that there is a executable with a $sign and foam user app bin and the name of the solver. So whenever you try to make a new solver, it should be important that this name of this executable should be foam underscore user app bin. So the this username is very important in this executable, otherwise it will try to make changes in the original solver. So this is about the .c file. And if you go inside these options, you see that the libraries and the other include files like finite volume mesh tools and finite volume, I mean library related to creation of the mesh. So this is the most basic solver of OpenFOAM that contains the information about the mesh generation libraries and where it should be compiled. So it is compiled in the user, I mean user folder, that is our run folder. Now we want to go inside the .c file, that is our uh, C++ files. So for that you have to open your editor. Hmm. If you see here what Pratyush has discussed in the last meeting, that these are the header files, that fvcfd.h. This fvcfd.h contains information about the CFD libraries, right? And any C++ code start with this main function. Here it's int main, or we can use void main. And there are certain arguments int arg and char star arg, meaning these kind of arguments are given when we do parallel processing. So the OpenFOAM comes with the by default parallel processing, MPI based parallel processing. So these arguments uh, are inherently available in the OpenFOAM codes. Now this has includes set root case.h is for uh, folder structures. So if you have gone through the OpenFOAM basic tutorials, where there are three important folders like zero folder, constant folder, and the system folders. So this has include is checking whether that folders are available or not. Now then there is a second header file that is called create time.h. So create time.h means the header file that is related to time, like uh, when we want to stop that simulation. Let's say we have ran the simulation for some time, and for some reason the power turned off. Now we want to start the simulation with the latest time. So any kind of time related information or the simulation, uh, that information is contained inside the create time.h. Now this thing represents the execution time and the clock time. So here we are not dealing with this kind of things, we are just simply trying to modify. We want to just know how to do the coding right from the scratch, so we don't need this kind of library, this header files and the other time related information, so we are removing it. Now let's say the first thing that we do in any kind
Excuse
of,
me,
yeah,
can you explain that welcome.c file once again?
okay. So as soon as uh, uh, as soon as we have just wrote this command foam new app welcome, that means we are directing the OpenFOAM to create a solver, and the name of this solver is welcome. So as soon as you just type this command, you see that this folder is generated. And when you go inside that folder, you see that by default welcome.c file is generated, and along with that a folder is generated named with a make. So inside this make folder we have two another files. One is the files itself, another is the options. So as I have told you, this files contains where we are trying to run this solver. So here we are going to run in our run folder, that is the user directory. So that's why foam user app bin. don't uh, don't remove the user part. And whenever you try to make whenever you try to make a new solver in future, just check whether the user this foam user is mentioned here or not, right? And the name of this solver is welcome.c, so here also the welcome should come. And again for options, so like here we are only, so this is the very basic uh, solver. So in from CFD point of view, if you try to make any solver, it has libraries related to finite volume and mesh. So meshing is the most basic thing in CFD. So it contains the information related to mesh. Let's say if you want to do some other kind of simulation where turbulence is involved, where porous media is involved, or multi-phase flow is involved, so based on your physics you need to include this executables and as well as the libraries. So let's say you don't know what kind of physics you are going to solve after 1 year, so based on your physics you need to remove or add the libraries here. This is for the options. Now
Uh,
again, going
Wait
inside this,
1 minute. In that options file,
hmm,
if you go, so you said that we have to configure this file as per the our flow physics, right? Whatever
yes,
turbulence model we are going to use, or
yes,
the
yes,
overset mesh, dynamic mesh, etc. So we have to fetch that related file information from SRC or application folder and just paste it over here, right? Only that we
yes,
have to
yes,
do.
yes, yes, yes. So if you go inside any of the tutorials, where the solver part, so you see that there are make files, and uh, I can go it for you. So OPT, right? हाँ, इसमें hmm. Then OpenFOAM 6. If you go inside any applications and solvers, so let's say very basic, no, don't take basic, as I am trying to explain. Like let's say combustion, so take any solver from combustion and there is a make folder. Go inside that option, you see that there are a lot of other things that are available, like thermo physical models, reaction thermo, basic, compressible, ODE. So like chemistry models, so these are the things you need to take it from this solver. So you just need to copy it and paste it on your solver that you are creating.
Understood.
हाँ, 32 वो कहाँ है? ओपन फॉर्म, हम्म, हम्म, ओके, रन में तो नहीं है। हाँ, so now, hmm, as I am using Pratyush system, that's why I need to ask him where I need to go, right? So coming back to this one solver. hmm, if you look into this solver, as I have explained, these are unnecessary things for now, so we are deleting it and we are adding our stuff what we are going to print. So in normal C++, like we use C out or C in. So here we can also use cout, but the by default way to print in OpenFOAM is info. So we are going to use info. So when we type info, then there is a two less than symbol. After that we have to put double quotation. So whatever we write inside the double quotation, that will be printed as it is. So huh. Now we have written this information, and this information would be printed uh, in the terminal, right? So this is how uh, so we can directly print this information. So for that, so as we have information, welcome to the second week of the workshop, and that double quotation is closed. After that, every line of this code should be ended by a semicolon. That means the compiler will stop reading whatever the content that is available after that. After saving it, we need to first compile the solver. So the compiling is done using wmake command. Huh. So as you can see that that solver is successfully compiled, and the name of is this welcome. Now once it is compiled, now as the name of the solver is welcome itself, then we just need to type welcome and see what will happen. Huh. So as soon as I pressed welcome, you see welcome to the second week of the workshop. That is what I have written on that .c file. But you can see that uh, the Pratyus at the rate Pratyus also comes just near to it. So why it is coming? So for that we need to again go there. Uh, so so in order to just give so in order to give uh, the new things to come from the next line, we have to type another things that is called endl. That the meaning of this endl is end line. So if we just run it again, so whatever changes you make here, right? Once you make any small changes, first step that you should do is you need to w clean. Means so first of all, again, I want to make you see something. If we go inside this folder that is make, as soon as we just run that first command that is w make, you see this folder is getting generated, that is linux 64 gcc dp. That means this solver is successfully compiled. And now if I just type w clean, then this part will be removed. You see now this linux 64 gcc has been removed here, right? So while doing any compilation, you need to check whether this uh, folder is deleted or not, right? Otherwise it will take the same data from the previous compilation. Now again, if you just so we have to again uh, compile by using the command wmake. Now if I just write the name of the solver, now you see that welcome to the second week of the workshop, and then there is nothing in front of it as compared to the this first case, right? Because we have added end line, right? Uh, Now let's say if we want to give, so there are certain things that I need to add, like there is a shortcut like we can slash n. Slash n also means end line. So you have to give this in place of endl. If you type this one slash and then it is also equivalent to end line. And then there is a, if you want to give space, then there is slash t. It's like tab. What tab button does is it just makes some spaces between the uh, wherever it is defined, it makes just certain spaces, right? So slash n and slash t, slash n does moves the next information to the next line, whereas slash t moves the information uh, from I mean by giving some spaces. So this is related to how we do the uh, compilation of the solver right from scratch, and that is the most basic part of the any most basic uh, code of any solver, any programming language. Now let's say, now let's move upward and try to add some more things, like let's try to perform some operations, right? So while performing some operations, the first thing that comes in our mind is how to do addition, subtraction, multiplication, division. And why it is necessary? Because when we do cfd simulations, after doing the cfd simulations we need to do the post processing, and post processing requires maybe, let's say I'm just giving one example. Let's say raindrop is falling right from clouds to the ground. So you can just by doing the cfd simulation you can just track, uh, I mean you can just visualize through cfd simulation that droplet is falling from top to bottom. But can you just give another information related to its vertical position, how it is varying with respect to time, and how the centroid of this drop is varying? So things like that, and how whether the drop remains spherical or it becomes elliptical. So this kind of information is required in cfd to give the information to the researchers who are referring to your papers or uh, your work, cfd work. So this kind of post processing is extremely necessary. For that you need to learn how to present your information in a better way. So for that you need certain variables, like, so like in original c++, like uh, like the basic operations, that is the addition and subtraction. So we need to store that values in some variables. So every variables in cfd has certain data types. For example, as you can see, the main is a function which has data type of integer, and it will integer means it will take integer values. That's why it is returning the value 0, not 0.0. It is only returning 0. Similarly, there are other data types like uh, int, right, double, float. These are the standard data types used in C++. But in OpenFOAM, there is a data type that is called scalar and label. Right. So what scalar includes is and what label includes. So scalar includes both float values as well as double values. So when you specify a data type with a variable that is scalar, the name of the data type is scalar, then it will automatically, by default, it will assume double, but it can assume float as well. If you specify whether you want to use floating or double, so double has more precision. So generally, most of the people uses this double data type, and label is nothing but it's int. So these are the important data types that you are going to use in your post processing. Now let's say we are defining a variable scalar. So the let's say we are defining a variable a which has value of, let's say, 6.3. Now if we want to have another variable which is defined by b and has value 8.2 and so on, right? And let's assign another variable c is equal to 5.5. Right, so we have defined the name these variables. Now we want to perform certain, like let's say you have performed CFD simulation and you got data of velocity, pressure. So you know the value of velocity and pressure, but you want to perform certain operations for the post processing like multiplication, division, and so on. So how to do it? So just like this a, b, and c are multiplied or operated, similarly, you can operate pressure and velocity from the CFD simulations. So let's try to see some of the basic operations like multiplication and division. So for that, first of all, uh, again we will type info, and in info we are stating that a, the value of a is now this, the pink color a indicates that whatever, so it will be directly printed in the terminal, but its value will be this a. So a here, and then similarly b equal to b. Hmm. So now if we run it, so again while running we have to first make the command w clean, then w make, then you have to write the name of the solver. So it is printing the value of a, b, and c, right? Now let's say we want to do some operations of, let's say, summation. So summation, it can be equal to a plus c plus c, and then you don't have to write this thing. So summation will be, so it will show the summation of these three uh, variables a, b and c, and similarly you can do the multiplication. Again you have to save it, close it, and then again w clean, then w make, then again writing the solver. As you can see, the summation is 20 and multiplication is 284. Likewise, you can perform other uh, kind of operation that is required in your post processing. Now, are you able to understand this part of the code? I think it's very simple. Hmm. Hmm. Ah. Now, we have done this summation directly here, right? But let's say we don't want to do it here, we want to do it somewhere else, because the actual cfd codes are not smaller. uh, it's very lengthy, so you don't want to mash up with your all your codes on a single place. So it's better to perform the post processing operation in other part of the code, which will be easily accessible to you uh, when you look it after an year or so, right? So for that we need to use the concept of these functions. So by using functions, we can do the similar operations but in different places. So for that, uh, the first thing that we want to do is we want to create a function. So I am creating a function here. Name of this function is, let's say, summation. So now, so when compiler comes here, it will see summation. So when compiler read this line, where it should go. So we need to define what do you mean by summation. So we need to define its meaning. So in summation we can define, so we don't have to write here, we can take this information outside. Hmm. Now when compiler comes, it read these three variables: a is equal to this much, b is equal to this much, and c is equal to this much. When it goes here, it sees that it goes then it sees this summation function, and when it goes inside this summation function, it sees that it has to perform multiplication and summation. So how this function knows that what value of what value it will perform the through what value it will perform these operations, multiplication or summation? For that we need to pass certain arguments. So here we have to specify this values, like we can directly specify here as we know the value of a. So a is passed as an argument, then b, then c. So these values are passed inside this function. Now it should take these values, but it should not take this value with the same like same variable name. So we have to define different variable name. So the name of this variables are, let's say we are defining it as x, y and z, right? So like here we have defined the function whose data type is int. Similarly here we have defined a summation function and it should have a data type. So we have to define a data type. Either we can define int. If we define int here, then we have to return some value, right? So the main function is not returning value, so we have specified 0, but here we need to return some value. So or either or let's say uh, we are performing two operations here. So returning two values of different operations are not possible. So that's why we can define another data type, that is called void. So by defining void, the function data type as void, then it will not return any value. Whatever the input it is getting, it will perform the operations here only. So it will perform the multiplication of x, y and z. So here we should not use a, b, c because it is inside this function. So now here we need to use these variables x, x, y and z. Similarly, hmm, again we have to make w clean, then w make. If we just type w make, some error might come. Yes. So why the error is coming? First of all, you need to understand. Hmm. So when we defined a void summation x, y and z, so what is the data type of x, y and z? That is not defined. So we have to define the data type of these three uh, variables. So here we have defined abc as scalar, so we can define here also it's scalar. Now as you can see, this that error is not coming. Why that error is coming? Because we have not we have simply taken xyz, we haven't defined what is xyz. So every variable or function that you will going to define have certain types, that is called the data type, and that data type you need to define it. So every time you make a new variable or new function, it should have a proper definition, otherwise it will inform you that this was not declared in this scope, meaning you are just using any values and you are trying to calculate something which it doesn't recognizes. So again, if you go inside, so I have compiled it, and you have to just run the solver, and you see that the same values are coming that we have got earlier, this one 284.13 and 20. So see how we can just shifted the calculation from the main file to a separate section, that is the separate function. Similarly, based on your requirement, you need to have a different post processing parameters that you need to calculate. So this can be done by using this information. So like I have used, as I have told you, I have used this scalar, which means it's double or float. Let's say we are defining it as a label here. Label means it will take int. uh, Now we have defined a is equal to 6.3, b is equal to 8.2, and c is equal to 5.5. And if if this function is called, then let's see what will happen. Again, any small changes you make, you have to first w clean and w make, and the name of the solver to run it. Now you see the values are different, right? Now it is 19 and it is 240. Why this difference is coming? So again, you have to go inside. So when we specify uh, any variable with data type label, then it will assume only the integer value, not the decimal part. So it will assume 6. The value of a is 6, not 6.3. Similarly for b, it's not 8.2, it's 8. Similarly for c, it's 5. So it will take here 6, 8 and 5 and perform the multiplication and summation. So this is related to the data type, how the use of data type are important in any CFD codes, like scalar or label or int or double or float. Similarly, void, or similarly, uh, let's say another operations. Let's say this can be again done using some different data types. So how to do it using different data type? Let's say we are using int here. So if we are using int, then we need to return it. So what we have to return? We have to return this one. Let's say we are not performing multiplication for now. So we have to return some value urn. So the value, since we have performed the summation and we have to return some value, so we have to return this value. So so we are doing the operation here, not here. So you have to comment, you need to comment it out here. Now it returns the summation. So now how you have to write is, you have to copy this part of the code and paste it here, right? Now you see that we want to sum that number, but summation we are doing somewhere else, which has data type of int, and it is returning means it is returning from where it is called. We are calling summation here. So first compiler goes here, and then when compiler comes here, it sees that I have to return means where it will return, from where it is being called. So it will go here. So again the answer will be same, but the way we are writing this part of the code is slightly different as compared to the void. So again, w clean, w make, the name of the solver. So it is saying summation is 19, right? So based on our requirement, we need to change, we need to decide what kind of data types we are going to use. Like let's say here, I have said that summation, right? So here I am performing only one operation of summation. Let's say if I have to do multiplication as well, then I can't return two values at same time, right? So in that case, if we are trying to perform multiple kind of operations like multiplication, division, subtraction, then it will be much better to use wide data type. And if you are just returning the single value of from some single kind of operations, then we can use either int or void. So it based on upon your utility, I mean what kind of your operations you are going to perform, and what post processing, that output parameter you want to see. So these are related to basic operations. Similarly, you can perform division and subtraction. So one more thing I want to make you understand the difference between this percentage and, so when we talk about division, then there are two symbols, this symbol and percentage symbol. So what does that mean? Let's say we are taking this, let's say we are changing the value of a to 6, b to, let's say 2, and c to, let's say 1. Let's take it 7. Now we are not doing the summation here, just for your information I am just doing the division. So division means it can do division in two ways. I mean based on, I mean what is our requirement. So let's say I am just specifying this as division 1 and division 2. So if we just do a slash b, and here if we do a percentage b, so here we are not, although the this function is defined, but we are not calling it. We are not calling it from the main function. Always the compiler always starts from the main function, and it will always move inside the main function first. And if it sees there is certain functions that is being called, then it will move to that function. Since we are not calling this function summation function, then compiler will not go here, right? So this part of the code will not be executed or compiled. So again going back to this one, w clean, w make. It is saying that it is saying some warning. unused variable, although we have defined, but in the operation we are not using it, so it's a warning, so you can ignore it. See, so the division 1 is giving us 3 and the division 2 is giving us 1. What does it mean? So when we do A divided by B, that means it will only consider the quotient part. That is 7 is 7 when it is divided by 2, it gives quotient at 3. But if you do A percentage B, then it will give us 1, which indicates the remainder. So in some of the post processing, there are requirement of quotient where you have to perform A slash B, and there are requirement where you need to deal with the remainders, where in some of the post processing where remainders are important, so you have to perform A percentage B. So this is regarding the very basic operations that might be required in your post processing, and I have explained this thing, the functions, how we are defining the functions. Now there is one more thing in functions, like here we have defined label which is integer, and we have defined scalar. So or what we can do is we can define a template. So when we define a template, it does not care about what is the data type. It will exactly uh, take the value as it is. For example, let's say this is 7.2, this is 2.5, and this is 1.1. Now in order to make it, so we have to define a template, template, template. Then we have to define this class, and we are just specifying a random data type. So it could be scalar, it could be integer, it could be double, it could be float, anything. So we are defining it as a t. Now as soon as I defined class t, then we can change this thing, like to, so then we don't need this scalar, we can use this t. Let's change it to, we have to perform this. A comma b comma c. So it is giving us some error. Let's see. So I think it is not taking that expected. Mhm. So these three data types should be same. I mean the data types should not differ. So that's why it was saying that here initially that no matching function call. So it here it's scalar and it is label. So it is saying so there's no matching. So in this way you can use this template also in order to perform uh, multiplications or divisions or other additional operations. Now we are going to so I want to show you something related to string operations. I think could you please wait for 2 minutes? If you have doubt, you can just ask in the chat box. Now I am going to show some of the strings operations. So this thing I have worked out because it is time taking. I have already. नहीं आ रहा? Am I audible? Yes, yes.
Excuse me.
Yeah.
Can we have multiple .c files inside this main folder?
What? Multiple?
If we suppose we have multiple number of .c files,
Okay. No, but
then
there is.
how to selectively apply wmake to a single file?
So generally we use only one .c file, right? The main which contains the main function, that is int main.
No, suppose right now we are editing the same welcome.c file. If suppose
Okay.
I, before making any edit, I just copy that welcome.c file inside the same folder itself. I will be having two .c files, right? One is the welcome.c and other I will copy and rename it to some other file. So how to apply
Hmm.
wmake in that case?
Uh, as far as I know, we don't use too many C files. We can make use of many .h files, header files, but I think there is only one C file that contains the main function. Have you ever gone through a case where you have multiple C files, or you're just asking?
No, I'm just asking.
No, no. Generally, we don't have too many C files, but because it's the main file, right? So we have many header files, that is possible, but we don't have many C files, .c files. And every folder should have only one C files. And you can check it uh, in OPT. Sorry. Applications, solvers. Let's take any solver. Uh, as you can see here, there are p equation.h, correct phi.h. .h files are there, but there is only one .c file. Similarly, if you just randomly choose any one of the other solvers, you see there is only one C files. So you can't have too many C files. For one folder, for one solver, there should be only one C file that contains the main function. So the main function here is this one, int main. So this is where the compiler it starts. So too many main functions are not required, or there is only one function that is sufficient enough uh, to for the solver. I mean, for any C++ code, there is only one main function that is the heart of the any C++ program.
Okay, and can you show how to use the log keyword? Last week we
For,
tried log, block mesh, etc. It is writing one text file for the operation.
for text file for the acha, that running code.
Mm-hmm.
Okay. So the mentors are typing in the chat box. You can just refer from the chat box. So I was telling something related to string commands. Hmm. So to save some of the time, I have just tried to do these string operations that are also performed in C++, and I think this will cover the most of the operations that might need in your CFD. So let's start with this string operation. So string means, like, here we have defined string means it will, string means nothing but a letters, some of, I mean, you can consider it as a word or letters, like. So here we are defining string. The name of this string is testing. So and we are defining what the testing string contains. It contains the information right from this end to this end. So whatever is inside this double colon, this double quotation, is considered as a string. Now what we do is, let's say, uh, let's try to run this one and check what it shows. First of all, you can w clean, w make the name of the solver, strings. So it is showing us welcome to the second week of OpenFOAM workshop. So as you can see, these spaces and these spaces are already there when we have this comment, this part of the information. Hmm. So it is printing from this command info testing. What is testing? This testing includes the string from first double quotation to the second double quotation. Now we want to perform certain operation related to string. So one of the operation is this operation. This is, let's say we want to trim some this, we don't want spaces here. So we are just removing this space uh, by using this information, trim left. Similarly, if we don't want to have this space, we can use trim right, and that is possible because of this string operations. So when we do any manipulation of the strings, then we need a header file that is called string operations.h, string ops.h. So if you include this header file, then only we will be able to perform this kind of operations. So let's see what the what results it is showing. It's not showing. Let's try to do it one more time. Strings. String. Huh. Now it is working. As you can see here, it has trimmed this part. The trim left means, and trim right means it has trimmed this part. So this part is not visible here. And if you look at this third one, it has trimmed all the spaces that are available on the left and right. Now this is related to trimming, and then other things are, now let's say this one, second line. What does it mean? For string constant iteration I is equal to testing begin less than testing end. What does what does it mean? Right. So here, what this string operation is doing is, it is going to this testing string, and it is checking each and every character. So here there is one space, and then there is a second space, and so on, and then there is a W, then there is a E. So every letter has some address. So it is checking what is the uh, initial address and what is the end address. So initial address starts with I is equal to 0. So 0 has string of space, and so on, and at the last also we see that at the end index of this string there is a space, and in between WELCOME, then space, then T, then O, and so on. So these are stored at specific locations of the strings. So we want to see what does this I print. So I will going to print the uh, the information of the string that are available at the specific address, like I is equal to 0 has space, I is equal to, I mean, at zeroth address we have space, at first address we have space, and so on. So we just need to check what it is printing now. W, it is not printed anything. It is showing the same information. Let me check. Hmm, where I have made the changes then. I think I haven't saved that changes. As you can see here, what it is printing, it is printing all the letters that are a part of string one by one. So why it is printing down? It's because uh, we have used this command that is called end line, ENDL. So it will first read a space and will go to next line, and then again read a space and go next line, and so on. That's why it is printing like this. So if we replace this endl, so as you can see, the all the letter of the strings are printed side by side because I have changed the endl to slash t. Now let's see some other operations. Now as you can see, there are certain operations like replace operation. What replace is doing, that it is changing this space with n, and so it will only going to replace only one of the spaces here in case of first this first command. Second command, it will replace space with nothing, so space, one of the spaces will be eliminated. And third line indicates replace all means wherever it sees e, it will replace with w, capital W. Similarly, wherever it sees these spaces, all the spaces will be eliminated at all the places. Similarly, the if it finds there is, if there is some, at some places if there is that letter the, then it will replace it with nothing. As you can see here, this is the first original line. In that original line, the first thing that we have typed was, instead of first space, the first space need to be replaced with n, so it has replaced with n. Similarly, the third line, the second line indicates that the first space need to be eliminated, so this welcome w, welcome is shifted on the left side. Similarly, all the smaller e will be replaced with capital W, so the smaller e is replaced with capital W. And the fourth line indicates that all the spaces need to be eliminated with replace all options, so wherever it finds space, that space are eliminated. Similarly, the last command was, if it finds the, it will eliminate, since it doesn't find any string related to that is the so there is no changes in the original line. So these are how you manipulate this files and the name of these files. So that might be required in post processing to rename the file names and to add variables, and how you are going to write the files, .dat file and so on. Now there is now we are going to see what does this dot expand does. So it expand the namespace, like here we are using foam run. So the what is the meaning of foam run in OpenFOAM? So it will try to expand this term. through using this expand command, and also this $home. Uh, so it is printing the original line foam run and $foam. So $foam run means it is the expansion of this $foam run is it is here home pratyus open foam pratyus 6 then run, and similarly this $home means it is in this address home and pratyush. Now we are going to see dictionary. What do you mean by dictionary? So we can create a dictionary by using this command dictionary and the name of this dictionary. So here I have defined dict. You can write your name as well. Then just like dictionary, we see that it has certain meaning. Similarly, we have defined OF. OF here means it means open form 7 or 6, whatever you are. I mean, I have just defined like this. Similarly, I have defined another dictionary with the name subdict. So in subdict, I am adding this value 1, val 1, and value 2. It has value of 3. Just like open form is expanded or can be understood as it means open form 7. Similarly, value 1 can be understood as val 1. Similarly, value 2 is understood as 3. And and there is one more command, that is uh, dict dot add form run subdict. Let's try to run this command one by one. So first of all, we are just adding this command. See what it has printed. It has printed this one. Open form we have defined like this, and it means open form. That is what we have defined. Now we have printed this part. Now we are adding something to it. So what we are adding is we are adding. So we have defined this dictionary. In this dictionary we have defined meaning of open form, and here we are adding one more thing, that is subdict. We are adding subdict, but what is subdict? So for that we have to define subdict first. So again, subdict is a dictionary, and this subdict dictionary contains meaning of two terms, that is value 1 and value 2, and both these sub dictionary are inside the dictionary. And if we print this dictionary, then you can see how the result changes. See, initially we have defined a original dictionary with the name OpenFOAM, and it means OpenFOAM 7. Then we have defined sub dictionary, and sub dictionary, as you can see here, this sub dictionary we are adding inside this dict. So this sub dictionary is a part of original dictionary, right? That's why it is printing this value inside this foam run, and that is the part of original dictionary. Now, just to check, uh, so why this is important, so you will get to know by this part of the code why this kind of dictionaries are important and why it is relevant in solver development. Now this thing you might have, if you have gone through some of the basic C++ I mean solvers, either icofoam or simple form, you might have seen this one: inlet, type, value, outlet, then type, zero gradient. So this is how you are going to create uh, this kind of template for the C++. So as you have as I have told you that you have, if you have might gone through that zero folder, then inlet, wall, outlet, where you define the type and you define the values. So the creator of this OpenFOAM uses this kind of concept to create this inlet, outlet, and walls, so that you can specify what is its value and what is the type that you are using. So this is the importance of dictionary in OpenFOAM. Now you might have seen in the zero constant and system folder. In system folder we have control dict file. Let's run it first. Huh. So what it is printing, uh, tilde operator, then OpenFOAM slash control dict is home Pratyush, OpenFOAM, OpenFOAM 6 etc control dict. So it is present in etc folder. So it is giving us the information where it is present, that control dict. Now let's say if we want to change something, the name of the original file, let's say you don't want control dict, you are creating your own solver and you want to name with some different name, then what you are going to do? So you can replace this uh, control dict with some new name. So that new name is, let's say we are giving the new name as new control. So this part of the code is telling you how to replace the control dict with this new control. So first of all, like here it will, so as it is clear from this part of the code that it's slash home slash pratyu slash openfoam slash. So as you can see, there are lot of slashes. So but control dict after control dict there is no slash. So first of all the code will identify the last slash. Then it will, if it finds there is no slash after that, then it will try to modify the content of that content after that last slash. So this is the string operations that will find this slash symbol. So the R find means it will find this slash symbol, and if it doesn't see any slash, then it will return -1. So like if it has, since it has found something, then it will, like, let's say if there are no slashes in this command, then it will directly replace this control dict to new control. But if there are multiple slashes available, then what it will do is it will try to find out the last slash and then replace the content after that last slash to control from control dict to new control. And after replacement we will see this result. So let's see this result. Hmm. So after replacement, this control dict is now changed to new control. Similarly, we have one more line after that. Hmm. So again, if it finds OpenFOAM 7, then it will replace with OpenFOAM 7. Here F is small, here F is capital, but there are no OpenFOAM 7 here. So it is not changing anything. So we will change this term OpenFOAM 6. So OpenFOAM 6, we are changing it to, let's say, OF6. That OpenFOAM 6 earlier, this OpenFOAM 6 is getting replaced with this one, OpenFOAM 6, OF6. Now there is one more thing here. Let's say we have defined a string, and here we are not defining right in the coding part. Here we want to uh, define the string at the terminal. So in order to make the user write that string, we use this line, that is sin dot get line s. So this will this will try to take input from the user side. So as you can see, it is not printed anything as I have pressed enter after this string solver. It is not saying anything. So because it is waiting for some input. So I am randomly pressing anything. So now based on our input, it is showing output. And what is the output? Output is this one, what I have just typed here. And it is showing that it has total 29 characters. So we have written a command for that, that's why it is showing that it has this many characters. So here we have here we are asking what is the length, what is the length of this string s2. So that's why it is saying it has 29 character. Similarly, cout and info, you can see the difference between cout and info. Cout, both are giving us the same output, but the way is slightly different. Here you can see cout does not contains this semicolon, yeah, sorry, double quotation, whereas this info contains this double quotation as well. So you can use any of them, it's just for understanding some of the differences. So this is the all the operations that might be required in OpenFOAM CFD related to strings. I think this much of operation is sufficient from OpenFOAM CFD perspective. So you don't have to know too much related to strings. If you are willing to learn it, you can just uh, copy this string operations.h and try to search in the internet, or string.h or string operations.h. You are going to get a lot of information related to strings. So this is related to string part. Now we are moving to another part, that is related to class. You need to, so you might have gone through the CFD solvers and various utilities functions, and you might be aware that it's not a simple C++ code. It's a object oriented based C++ coding. So first of all, you should know what do you mean by object oriented programming. So object oriented programming means it has various features. Features like it has inheritance, classes, polymorphism, encapsulation. What does it mean? So from the user point of view, as the most of the CFD users are not the core developers, so it is not necessary to know what is deep inside the coding of OpenFOAM. So this part of, I mean, this concept of object oriented programming, that is called uh, OOPS, uh, it allows you to know the things which are relevant for from CFD point of view, and there are other certain things that are not relevant as a CFD engineer. That's why they have hided the information. So this comes under uh, concepts of object oriented programming. So today we are going to understand few things related to classes. First of all, you need to understand what are classes. Just like I'm giving you one example, like all the flying birds like peacock, you can take crow, sparrow. These are birds, and it is coming under the class of birds. And what are the characteristics of this class? All are birds, and all can fly, and both has two legs only. I mean, all these birds have two legs only. So these are the specific kinds of information this particular class is giving. Let's say if I ask you what are the characteristic of a bird, then uh, you will quickly say that it has two legs and it can fly. Similarly, so this kind of information, or the, I mean, from CFD point of view, or the from C++ point of view, there are certain areas the where the characteristic of a different kind of operations are same, so we keep it under a same class. Similarly, if you take animals like zebra, camel, dog, so if you ask me what are its characteristics, then I will say they have four legs and they can run. So these are the characteristics of an animal, right? Similarly, you can see in from programming point of view, there are operations or where there are information which has certain characteristics or certain patterns. So we try to keep that in a separate class, so that it will be very easy for us to access the information uh, in a short period of time and very quickly without writing too much of a code. So it reduces the uh, code, I mean understandability as well as the writing part of the code. Otherwise our code will become very long. So it can be used to shorten the code as well, and it can be used to uh, hide the unnecessary information that is not relevant. So we are going to learn about uh, this classes now. So again I am creating a new solver with name class. So again, whenever we create a new solver, it comes with this by default this header files and this information related to time that is not required here. So we are eliminating now. Now, as I have told you, classes. So most of the C++ code, if you go deep inside the solver, you might see uh, different kinds of uh, different kinds of the functions and objects and classes with different uh, characteristics. So that initially will become very time consuming to understand what does it mean. So today we are going to learn something related to classes. It will be very introductory. In the from tomorrow we will cover the details related to classes. So now let's start with the classes. So I will try to just explain this the concept of class through a problem. Uh, the problem is what is the pressure drop through a pipe, right? So the pressure drop through a pipe uh, is dependent upon uh, the viscosity of the fluid, flow rate, length of this pipe, and diameter of this pipe. But as you can see that any pipe will involve this parameter, but there is a possibility that we have thousand number of pipes. So if we have thousand number of pipes, we need to write many line of code to just calculate the pressure drop. So can we simplify this problem using some concept? Yes, so we can do it by using classes. So let's say for thousand number of pipes, what we need only the values of viscosity, length of the pipe, diameter, and flow rate. Then it will automatically calculate the pressure drop. So we are going to understand uh, how to do it in classes. So first of all, uh, we need to create a class. What is the name of class? So we are defining a class here, class, and we are, what we are doing in class, we are calculating the pressure. Hmm. So why classes are special? Classes are special uh, because of its accessibility. So in classes we can access its content or data using three ways. So there are three ways where the data of class can be accessed. One is public mode, one is private mode, and third is protected mode. Public mode means whatever we will define inside this class. So we have defined this class, calculate pressure drop, and whatever we are going to define here, that can be accessed from the other part of the code as well if we give the accessibility as a public. So here we can define three ways. What are the three ways? Public, and private, then protected. So under public, it's just like a function. Let, and every class it's like, we can define functions as well as the variables, both can be defined. So that are called uh, data members and member functions. So in class we have data members and member functions. So data members are nothing but data type, like we have defined earlier, right? Scalar ABC or label AB, that is nothing but data type, and here it is, here we call it as a data members. And the normal functions that we have created earlier, that is summation function, that here it is called member functions. So here we can define both, like, so I think it is 10 p.m. Are you all awake or someone has slept? Would
No,
you
no,
like to
we are awake. We are awake.
would you like to continue, or I will cover the same thing tomorrow?
We can continue for some more time.
Okay. So in public, so what I am trying to say is, uh, public can contain some scalar values, SCA scalar, let's say. So if you look at the, first of all, we are calculating the pressure drop, del P. The formula for pressure drop is 128 into viscosity into flow rate multiplied by length of the pipe divided by pi into diameter to the power 4. So this is the expression for pressure loss through a pipe. So we need these parameters to calculate the pressure drop. So for that we need to define the this variable. So let's say we are defining here. So it's mu then flow rate L, sorry, flow rate Q, length L, then we have diameter. So these are the four variables required in order to calculate this pressure drop through a pipe. Now we can define this mu, Q, L diameter in public, either in private or in protected. So it depends upon our choice. Let's say if we are defining scalar mu, Q, L and diameter inside public, then from here we can access these values. Let's say if I write what is the value of mu, then it will uh, give us the value of mu from here. But let's say if we define the same thing here, then if we try to know the value of viscosity from this part of the code, then it will show an error. It will it will tell that this part of these data members are private, so it will not be able to access that value. So let's say define this thing in the private, and then let's say we are defining the public. So we are defining a function to calculate this pressure drop. So in order to do this, let's say we are uh, so this flow rate is nothing but area into velocity. So let's say we are not giving this flow rate, we are giving velocity. So if we have velocity, then we need to calculate the flow rate first. So let's calculate the flow rate. This flow rate will contains uh, information that is related to area and velocity. So it will again take some values, right? So it will take velocity and this one diameter. So q is equal to uh, pi by 4 d square into velocity. Now we have defined Q. We have defined the data type, that is mu, U, L and D. Let's say we have to define one more function to calculate the pressure drop. So either I can define, just like I have defined this flow rate, the evaluation of flow rate inside this function only. You can similarly define the drop value, that is this formula, inside this public domain like this, or you can define it outside. Let's try to define it outside. So when we are defining it outside, so this drop value, let's say we are defining it as a int. So int drop value, hmm, okay. I think I got to know that many people have left the session, so it will not be good to continue now. So we are going to continue this part of the session tomorrow. Uh, so I would request all of you to uh, perform the experiment. Sorry, the exercises that has been uploaded now in the chat box. Try to complete that exercise uh, by tomorrow itself. And if some problem comes, you can discuss with us, right? And also, I would like to go through this part of the today's session. This is classes, related to classes, and the other stuff related to strings and functions. So if you just try to replicate the same thing in your system, it will be very easy for you to remember it for a long period of time. So that would enhance your learning in OpenFOAM. So I would request all of you to just go through the video once again and try to replicate the same thing, and also do the exercise, and the doubts related to exercise and other stuffs will be taken care of in tomorrow's session. Okay, so we are done today. We will meet tomorrow. Thank you, all of you.
Thank you.